Good morning, girls. Today I'll be discussing some important properties of light, which is reflection, refraction, total internal reflection, and dispersion. Of course, there are so many other properties of light, but still, we're just going to restrict all our discussion according to your syllabus. So the first important topic is refraction. So just look at the figure. So this will give you information. So the white color region, which is one medium, and the blue region, it is some other medium. So when the light passes from one medium to another medium, which is the red color line. So when the light passes from one medium to another medium, you just look, there is a slight bending of the light rays, right? When it crosses one medium to another medium, once when it hits the interface, there is a slight bending of light rays. So this kind of bending of light rays when the light passes from one medium to another medium is said to be the refraction of light. So this is something very important because the properties of light, all the properties of light, such as uh, reflection, refraction, it all involves the bending of light rays. But at what medium the light is going to bend, that is very important. So here the light bends when it travels from one medium to another medium. So this is refraction of light, and the next one is reflection of light. Here of course, the light actually, it just hits the interface. It The yellow color line, it just hits the interface, and it actually bounces back to its own medium, right? So unlike refraction, where the light actually it actually makes a transmission from one medium to another medium, and only when it makes a transition, the light ray actually bends. But whereas here, in this case of reflection, the light ray bounces back to its own medium. So this is also bending of light rays, but the light rays actually bend or bounce back into its own medium. So this is said to be reflection. So the next one is all about diffraction. So diffraction is something about the bending of light rays again. So you might, you may have some doubts on the concepts of light, where everything involves bending, right? So here it is something uh, where the bending of light rays happens around the edges. So just uh, look at the figure. The phenomenon of bending of light rays around the corners, right? We call this as diffraction. And of course, there are so many types of diffraction, such as Fresnel diffraction, Fraunhofer diffraction, and yes, of course, we have so many types. But still, this is enough for you, which is bending of light rays around the edges is called as diffraction. So the next important topic is dispersion. So here you just look at the figure where we have taken a glass prism and just a white light, right? A white light is going to get incident on the sides of the prism. So once it hits the sides of the prism, the white light gets dispersed into 7 different colors. That is the Woodgyar colors: uh, violet, indigo, blue, green, yellow, orange, and red. So this property is said to be dispersion, because all the light rays are getting they get dispersed, right? So a single white light is getting dispersed into seven colors. So we call this as diffraction. Sorry, a dispersion. And the next topic is total internal reflection. So here you just see uh, again, the first figure is very clear, which is the concept of refraction. There is a bending of light rays from one medium to another medium when the light travels from one medium to another medium. and this is purely the concept of refraction. But what happened when the angle of incidence increases, right? Just look at the value of theta 1. But what happens when the angle of incidence increases? So when the angle of incidence increases, the angle of refraction, just look at theta 2. Compare theta 2 value of the first figure and the second figure. So in the second figure, theta 2, the angle of refraction, it increases to 90 degree, right? Which is the refracted rate actually just grazes the surface of the interface. So this is said to be the critical angle where your angle of incidence, it's something equivalent to the critical angle, which is theta c. So in the third figure, you just see there is no refracted ray at all. When you further increase the angle of incidence, which is uh, when your theta 1 is greater, right, greater than the critical angle, there is no refracted ray at all, and the ray completely falls within the medium, right? So this is said to be the total internal reflection. Yes, thank you all.